Here's the first problem set for binomial expansion. Um, a plus b is called a binomial because it contains how many terms? By two terms, okay? Any expression of the form a plus b to the n is called a power of a binomial. Consider the expansion of the general expression a plus b to the n, where n is a natural number, which means it's 1 through whatever, a positive integer, positive whole number. The binomial expansion of a plus b squared is, and then there's two ways you could do this. One is you might have it memorized. The other is you use FOIL. And if you have a plus b times a plus b, then you would say, okay, I'm going to multiply the first two terms together, I get a squared. I multiply the middle terms together, I get ab. I multiply the outside terms together, I also get ab. I multiply the last two terms together, I get b squared. And you notice that these two are the same, so we could simplify this. We could write a squared plus 2ab plus b squared. Okay, and you might also have that memorized. Now, you might not have a plus b cubed memorized, and that's okay. But since we just calculated a plus b squared, we could already write that a plus b cubed is actually a plus b times a plus b squared, right? So what does it look like? It's a plus b times, and then we could just write this expression in there, right? A squared plus 2ab plus b squared. Now we could just use the distributive property, and this isn't really FOIL anymore because FOIL only works with two binomials. When you have a binomial times a trinomial, what you would do is you would just, multiply all possible combinations. So you would multiply those combinations, and then you would multiply these combinations, and then you would have 6 terms, and in some cases they simplify. And now you're going to remember our investigation, right? So first I'm going to do the red multiplication. So I'm going to get a cubed plus 2a squared b plus ab squared. Now I'm going to do the purple multiplications. I'm going to get ba squared, which is actually a squared b. I'm going to get 2ab squared, and I'm going to get b cubed. And I wrote these out in this way so that I could add them up in a column. So if I add these up, I'll get a cubed. If I add these two up, I'll get 3a squared b. If I add these two up, I'll get 3ab squared. And then I'll get b cubed. And now you'll remember that Pascal's triangle gives us 1, 3, 3, 1. So that's a way to memorize this without too much effort if we use Pascal's triangle. Okay, so a plus b cubed is that. Okay, so use the binomial expansion of a plus b cubed to expand and simplify. And so now whenever we have something in the form a plus b cubed, now we don't need to go through and multiply everything. All we need to do is figure out what a is, figure out what b is, and then substitute everything. And then, for the p plus q case, it's very easy, right? So our p is actually a and q is actually b, okay? So we'll just say, okay, we're going to take our expression here, and we're going to take all our a's and we're going to change it to p. And we're going to take all our b's and we're going to change it to q, and that will give us the result for a. So it would be p cubed plus 3 p squared q plus 3p q squared plus q cubed. Okay, that was easy, wasn't it? What about for e? 3x minus 1 cubed. So here we would take all our a's and change it to 3x. And we would take all our b's and we change it to negative 1. This is a little bit more tricky because, you know, with the negative sign and the multiplication of the constants, things are not that easy, right? So remember, we're going to change a cubed plus 3a squared b plus 3ab squared plus b cubed. We're going to change it so that all the a's are 3x's. So that a is going to be 3x cubed, and then we're going to have 3a squared, so that would be 3x squared b, which is negative 1. And then we would have 3 times 3x times negative 1 squared plus b cubed, which is negative 1 cubed. Now you really need to be good at your exponents that hopefully you reviewed in our past unit. Negative 1 cubed is negative 1. 3x cubed is 3 cubed times x cubed, so that would be 27x cubed. 3 squared x squared negative. So the negative from here, we can put it out in the front. 3x squared would give us 9x squared. 9 times 3 is 27. Okay, and you know, I'm not writing every single step out here, but you should if you're not comfortable with this. Negative 1 squared is positive 1, so that kind of disappears. 3 times 3x is 9x. Okay, and so now we're done. We have 27x cubed minus 27x squared plus 9x minus 1. And, you know, remember how it was 1331? This does not look like it's 1331 because our a value had a 3 in it, our b value just had a 1 in it, so it's totally irrecognizable, right? What about c? In this case, a would be x and b would be negative 3. So we do the same thing again. We're going to do a cubed plus 3a b squared plus 3a squared b plus b cubed. So negative 3 cubed is negative 27. 3 times 3 is 9. Negative sign comes out front. X squared. Negative 3 squared is just positive 9. Okay? So again, the coefficients look completely different than Pascal's triangle, but it's because a was, the constant was 1, and b, the constant was negative 3, so it just comes out looking very strange. Let's do g. In the case of g, a is going to be 2a, and that's kind of confusing because we have a again. B is going to be negative b, and that's again confusing because we're using b again. But these b's are not the same, these a's are not the same. So basically what you're going to have is, okay, I'm going to have 2a quantity cubed. Then I'm going to have 2a negative b, and that's going to be squared there. And then it's going to be 3 times 2a and negative b squared. And then I'm going to have negative b cubed. And again, 2a quantity cubed is actually equal to 8a cubed. This is going to be kind of a complicated mess. The negative is going to come out front. 2 squared is 4, 12, a squared b minus or plus, that's going to be a 3 times 2a, which is 6a. Negative b squared is actually just b squared because the minus sign disappears. Negative b cubed is actually going to be, it's going to be a negative b cubed. Okay? And then I, same thing, except a is going to be a 2x, b is going to be a 1 over x, and this is kind of a different one because you've got a fraction or a ratio here with the variable in the bottom. And let's see, I'll show you the first couple terms just so you can see what it looks like. You have a cubed plus 3 times a squared times b, and then you'd have two more terms, right? Well, let's simplify this term just to see what happens to it. 2x quantity squared would be 4x squared. So 3 times 4x squared, and then times 1 over x. So we have x squared times 1 over x. That leaves just an x, right? And then 3 times 4 is 12. Okay? So you see how that works? When you have the b term, which has the variable in the bottom, sometimes that variable is going to cancel out with the variable in the top. It's going to make it look a little bit different also. Okay. I'm not going to do that one all the way to the end, but do that if you need to. Again, for this one, this is quite a bit more complicated because it is a fourth order. Okay, so remember Pascal's triangle, the fourth row is 1, 4, 6, 4, 1, and we can see it there. Okay, so I'm going to pick one of the complicated ones, like for example this one, and I'll do this one for you because the other ones, I'm sure you're getting the idea. So here a is equal to 2x, right? And then b is equal to negative 1 over x. So they were nice enough to write this out for you, so I'm not going to rewrite it. A to the fourth would be 2x to the fourth. The next term would be 4 2x to the third, and b was negative 1 over x. 6 2x squared, negative 1 over x squared. 4 2x negative 1 over x cubed, and then finally negative 1 over x to the fourth. Okay, so 2 to the fourth times x to the fourth is equal to 16x to the fourth. 2 cubed x cubed would be 8x cubed, so that would be 32x cubed times negative 1 over x, so we can simplify that more. 2 squared x squared would be 4x squared, so that would be 24x squared times negative 1 over x squared. Negative 1 over x squared is just 1 over x squared, okay? And the negative sign kind of disappears because it multiplies times itself. And okay. Now here we would have negative. The negative from here would come up front. 2 times 4 is 8x. 1 over x cubed. And then the last one, we have 1 over x to the fourth. The negative sign disappears because it multiplies times itself 4 times. So let's see. We just need to simplify this one, and this one, and this one. So the first term and the last term are as simplified as they're going to get. 32. We got to keep the negative from here. We put out front. 32x squared, right? And then this one would be 24, and x squared would cancel out with x squared. It's just going to be 24. And then this one's going to be minus 8, and then x on top, x cubed on the bottom, so that would be x squared on the bottom. And then we have 1 over x to the fourth. Okay? Okay, so yeah, that's kind of a big mess for this, for I. Let's see. Now we'll do A and C here. Expand and simplify. And now you don't have to do all of these. Just do enough so that you're confident that you can do the quiz and you're confident that you can do the test. Now remember, for 5, you could just do Pascal's triangle to get the coefficients for 5. Remember, 4 was 1, 4, 6, 4, 1. I think 5 has a 10 in it. Yeah, it's 1, 5, 10, 10, 5, 1. Okay? So it would be x to the, I'm sorry, let's use a. A to the 5th plus 5 a to the 4th b plus 10 a to the 3rd b squared plus 10 a squared b to the 3rd plus 5 a to the b to the 4th plus b to the 5th. And so let's pick let's pick this one to do for you. So a would be 1 and b would be 2x. Okay, so for example, this would be 1 plus 5, 1 to the 4th is just 1. B is 2x. Actually, this one wasn't so hard after all because it's got a 1 in it, right? One. Okay, so actually this isn't so complicated. 5 times 1 times 2 is 10x. 10 times, this would be 4x squared, so that would be 40x squared. This would be 2 cubed x cubed, that would be 80x cubed. 2 to the 4th is 16 times 5, some big number, be like 80 also, is that right? 16 times 5 is 80, I guess so. X to the 4th plus, and 2 to the 5th is 32, x to the 5th. Okay, so yeah, that's pretty messy too.